Okay, good morning to you all, and as you all know, there's been lots of ups and downs to finally get to have a FunGIS conference. We've had all sorts of stops and starts with COVID, but we're certainly able to sort of hook into it now and see what we get. Okay, so I work for the Queensland Department of Agriculture and Fisheries. I'm a Senior Development Officer. My role is supporting farming systems, particularly coastal farming systems, and I've been operating in this role now for about 7 years, and I'm actually located in the region, so I live down in Innisfail and in amongst the farming communities. Right, I'll just run through the contents of the talk. I'll explain why I'm in this role, what my background is with drone technology in particular, what drones are doing in coastal cropping systems, and how we're combining the drone-based photogrammetry and the information that we get from it into what we're calling precision agriculture these days. So it's an integration of multiple technologies to improve farming practices. And I'll also just touch on a little bit what more we're hoping to be able to get from drones and do with drone photogrammetry as we move forward. Okay, so the first thing would be is why I'm in this position, and it's pretty much because of high rainfall that the proximity to the coast is a very important part of it. If we were somewhere else in Australia, they probably wouldn't fund my role, but because I'm on the coast, located on the coast, we've got very high rainfall, operating within farming systems that can leak farm chemicals and sediments out to the Great Barrier Reef. And DAF overall is sort of working on this problem. So my role is improving reef water quality, and we have a wide range of people involved in the reef space to work with growers, work with industry to improve Great Barrier Reef water quality. And we perform all sorts of trials around the place. So nitrogen trials would be the most common one that people would hear about, but we do just about everything from sediment to herbicides and pesticides and insecticides. We've got sort of cover almost everything. We do all sorts of crop yield, disease, just everything DAF's involved with. And so what I thought I'd do first is just show you a video that DAF's produced, and it gives you a bit of an overview of what I actually do, and then the rest of the talk will sort of drill down a little bit and get involved in some of the other aspects. There it is, somewhere there. Let's get a hold of it.
My name's Marcus Bulstrode, and I work for the Queensland Department of Agriculture and Fisheries. I'm working with growers to better understand their farm, taking it from managing the farm as a big single unit to reducing it down and managing it as separate small management units. This could be an area of just a few square metres, or it might be an area of a few hundred metres. It's a very exciting time to be in agriculture. New technologies such as drones are providing a whole range of new tools for us to be able to better manage farms. What we actually do with the drone, we'll put the drone up in the air, we'll fly over the crop, that might be at 100 metres or so. The drone is looking down the whole time with its sensor, and it's basically taking high resolution images of the crop. Drones come with a range of sensors these days. The typical one that I would use would be just an RGB, a red, green, blue sensor, so if you like a standard camera. But we also have multispectral cameras and thermal cameras. So we have some very specific sensors that we can tune to identify the character that we're interested in. I then go back to the office and I can process those images and start to unlock where the areas of difference are across the paddock. I've stitched together all of the images, and now I have a single orthomosaic high-resolution image of the paddock. If we look over here where there is no vegetation, we actually can't really see much going on at all. What we need is what we have here, where we've got a crop. Suddenly we can see all sorts of variability, and it's the crop that actually shows us the difference in the growing conditions, and that's a very important aspect of it. Ideally, the crop needs to be a bit over 1 metre high. I need to get enough leaf matter to be able to be seen by the drone clearly above it. In some cases, it's much easier to visualise the problem that we have using a 3D model. But I can zoom in and have a look around to see, okay, what did it actually look like on the ground? What was the effect that the growing conditions were having on the cane? in a 3D perspective, it's actually very easy to see the difference in the growing conditions. I can see the area that I'm particularly interested in. If we look back up here, another area where it's doing very poorly compared to relatively even the rest of the block. So I can zoom right in on that area and have a much closer look to see, yep, that's very poor cane through here. There's all sorts of weeds that have dried off. That's the area that I want to be able to go back into that paddock and see what's going on. I can run it through a couple of different algorithms here, a colour-coded elevation model of the paddock, blue being low, red being high, and we can see that this strip where the cane is not doing well is lower and much more open. So this is exactly the sort of area that I would then go into the paddock and start trying to work out why, and can I actually change that zone to make it better for the sugarcane. What I can do is take a marker, put that marker into this image. That marker is now a geo-referenced point that I can go back to with another device, such as an iPad. I can walk back into this paddock and stand at that precise point and know that I'm in the middle of the area that I'm concerned about and start to do some analysis to work out, okay, how can I fix it? And this is exactly the sort of thing that I would say to myself, I need to do some soil sampling, some testing of that area to see why is the cane not doing well. So using the drone mapping, I've been able to identify a part in the paddock where the cane was not doing well. I've extracted a soil core from this zone. I'll be able to analyse this soil core and start to understand what the limiting conditions may be for crop growth. Up here where the crop's growing, we've got roots, got organic matter, things that we need to have. We start to get a colour change as we come down through the soil profile. We've got now an absence of roots. There's nothing growing down into this part of the soil. And then when we get right down here, we've actually got, that's virtually beach sand. There's just nothing there at all. No clay, no organic matter, so not a good growing medium and something that would be needing to be treated to be able to grow cane properly. And in many cases, I should be able to improve this area to make the crop grow better. Remember that previously this paddock would be managed as one unit. It gets the same fertiliser, the same cultivation, everything is put on identically across the whole paddock. And yet we know that there's actually different growing zones. Some areas grow better cane, some areas grow poorer cane. Utilising the drone technology, we're able to target those areas of difference. We can then start to manage them separately. So for example, with this farm here, we're actually trialling some different techniques to improve the soil in those poor growing areas. We're going to actually add some organic matter and some clay and see whether we can increase the water holding capacity and also the nutrient holding capacity of these soils. The great thing with drone technology is it provides the base maps for other precision equipment. For example, variable rate fertiliser boxes, and what they require is relevant mapping products that can go into the tractor. We've got a smart implement on the back of the machine and it can alter its fertiliser rate within the paddock as it's going along. So the best outcome is for the crop to take up the nutrients that we're applying. We don't want nutrients leaving the paddock. The grower doesn't want nutrients leaving the paddock heading out to the Great Barrier Reef. We want the crop to use them and to grow a large crop. The same thing applies to weed management, that typically across a paddock we've got areas that produce more weeds and some areas that might produce fewer weeds. So if we're putting out herbicide, we might want to put it out particularly targeting those zones of high weed load. Whereas the areas that don't have weeds, we might say to ourselves, well, I don't need to put any herbicide out. There are significant efficiency gains for both the grower and also for the natural environment. The other great thing with the drone mapping is that we can compare it to other mapping systems. For example, EMI, which is electromagnetic induction, where we actually can measure the differences in the soil properties. We can now compare that to the crop yield above those soil differences and to see how well they match together. There are many uses for drone mapping for precision agriculture. One example here is flow mapping. We can actually create the surface water flow model for the land that we're interested in. So that means that we can design drainage networks, all sorts of other earthworks based around the drone mapping. In the near future, I think some of the biggest developments are going to be in AI, so artificial intelligence. For example, automated weed recognition, where I can fly the paddock, put the data set through an AI program, and it will automatically find the character that I'm interested in. It might be a particular weed, and it will identify how much of the weed is in the paddock and whereabouts it is located. The great thing with drone technology is that it is actually accessible to growers. The machines are quite advanced, quite technical, but they've reached the point that they're almost consumer level these days. So a grower can go out, buy a machine, get a bit of advice on what he may want to be doing with the mapping side of things, but basically a grower can go out and do his own crop mapping and then engage with an agronomist or an advisor to understand those different zones. I've been flying farms for about the last 5 years, and what has really struck me has been the amount of variability that there is across the growing regions. At first we used to think that farms were fairly even, but the drone mapping has revealed that most farms have a high level of variability. We just didn't know it before. We now have a tool where we can easily identify that variability and set about doing something about it.
Oh no, don't go again. So, now, if anyone's got any particular questions as I am speaking, I'm happy for you to ask them, so that's not a drama for me to sort of work around specific questions. So as I've mentioned through that video, that part of the solution to all sorts of problems is precision ag, and particularly around greater efficiencies, greater spatial understanding of what's going on, and then the management activities that we can target in specifically around those zones that we identify. Now on the GIS side of it, I'll just put my hand up and say I'm a sort of a GIS amateur who fiddles around with all sorts of things, but I don't have enough time, unfortunately, in my job to be dedicated to doing GIS. I did do it at uni, and I've been involved with all sorts of GIS type stuff ever since, but I do realise that I'm speaking to an audience of basically GIS experts, so there'll be some things that you'll think, oh, that's a bit funny to say that, but the GIS side of it for me is this incredibly interesting tool that I can use to do my other work, and it's a case of me finding enough time to bring in those GIS understandings and skills. All right, let's... okay, so I started in drones, I think it's nearly 10 years ago now, but about 9 years ago I was at JCU. I was doing a PhD project, which I opted out of, but I spent about 3 years fiddling around with drones, and that was back in the day where you purchased a drone and you soldered it all together yourself, you hacked camera software and did all this sort of thing, and it then flew off, and if you were really lucky, it came back. And of course things have changed so dramatically in that time that we now have such a range of incredibly capable drones. We also have an incredible range of capable sensors. So from our RGB standard sensors to multispectral and of course the thermal, which I mentioned in the video. We also have fantastic software for automated flight, for being able to do the flights that I need to do. In the beginning you had to put all these waypoints in and fiddle around and you could have got things wrong. Now it's just all automated and incredibly intuitive. Here's a picture of my office. So that's what, to me it looks like a GIS person's office, if I can say that, because really it's about spatial data that I'm really dealing with in the end. I'm using the drone to capture that spatial data, and in some cases, such as the spray drone, I'm tasking drones with going out and dealing with that zone, but really I'm working around spatial information. Okay, so drones do make you very popular. I've made a definite link between bringing out a big drone and the amount of people at a presentation that'll come up, especially at growers' meetings. And I get to speak all around the place. Drones are becoming more commonplace, but even in the length of time that I've been in it, there's still a really long way to go before people understand how easy the technology is to interact with and the huge range of benefits that come from utilising it. And I support many groups. So in my work, there's many people, particularly in natural resource management or in farming systems, that will interact with me, and I can give them the heads up often on the sort of machine and the sort of tasks that I would do. I often have people into my office, had someone yesterday, who wants to develop their drone-based skills, and then we can see how it fits in with their other skill set. One thing I will say is that I do get a lot of people that say they've got particular technology skills and they think, okay, well, I'll buy a drone or I'll just go into agriculture. It's probably one of those fields where you do need a certain amount of agronomy behind you to really understand what you're doing, and then you also need to have a bit of sort of tech stuff to go with it. Okay, so I'm just going to run through just the simplicities of performing a mapping flight that I would do. It's going to be an automated flight, so here would be some software that would grid up the flight for me. It's automated takeoff and landing, so I simply get to the site, bring up that flight path, and the drone goes off by itself and does all of the mapping. Of course, with the Civil Aviation Safety Authority regulations here in Australia, it has to be line of sight the whole time to the machine. I can't fly above 120 metres, can't fly within a 3.5 nautical miles of a manned airport or a controlled flight area. There's a whole range of conditions that you have, but most of them are pretty sensible ones, and then you can put a machine in the air and collect your mapping set. All right, so the thing that I'm particularly interested at the end, once the drone has done its flight, is that micro SD with those images. The drone flight's just a thing. Once I've got those images, that's when it really starts to get going, and to me that's the huge advantage on the GIS side of it. You've got that, what can turn out to be a spatial data set, super high resolution with many, many other apps and software systems that can utilise that data. Bit of a jump. So I bring the images in, they just come in as individual images, but they're all overlapped and on that gridded flight. And then I can process them on my, these days pretty much a standard laptop will do the processing. But what's happening increasingly, it's cloud-based. So you subscribe to a cloud-based service, and you can simply upload the images to the cloud and have them processed. And there's 4 standard products that come out from a photogrammetry flight for a drone, and one would be the first one would be the orthomosaic, and it's probably still the most important one of all. So I can just use my eyes. I can look into that orthomosaic and see all sorts of things that are going on, particularly around variability, and make decisions if I wanted to with nothing else but that particular product. It's all geo-referenced, GPS geo-referenced, so I can go into those zones and interact with it on the ground to see what's going on, and I can make up polygons and do all sorts of things around it. The other standard feature these days is running it through an algorithm. This is RGB imagery, but it can go through sort of a heat map interpretation of what the crop is doing. Red poor, green good. And the other thing that's created through the triangulation of the individual images is you get a digital surface model, and that's a really useful other product. Here we can see blue is low, the coming through to the orange is almost red is the high, so I can see not only the landscape level changes, I can see what it's doing to the crop canopy, how that's influencing the growth. I'll just give this one a whiz, I think. No, next one. You guys would know this, but I just want to run through it very quickly so you can see there's no audio on this one, Gary. This is just showing you that in that image that I'm looking at, it's actually captured 3D data, so it's a point cloud. And this is another really powerful part of the drone imagery, is that I end up with this point cloud that I can process through LiDAR, processing software, a whole range of things now to extract another lot of information from that, what would otherwise be a 2D mapping exercise. And that's a standard capture with all of those flights. Okay, so the thing that I'm particularly interested in and that has really jumped out in the years that I've been doing this, these mapping flights, is the variability. So used to go to a farm, we would put out trials, we would interact with growers, assuming that a block or a paddock was somewhat even. And because of the resolution of the drone imagery and the times that we're able to do the flights, we can sort of do it pretty much when it suits us. It's ended up showing that variability is enormous. It's massive across paddocks. And as I mentioned in the video, the importance of variability is that if we're treating those management units as a single entity and doing all the things evenly across it, we're really missing out that we've actually got zones of difference, zones that are not responding to what we're doing, and so zones that we can potentially go in and either reduce the rate or change the farming practice to increase the yield within those zones. Out of the audience here, can I just get people to put their hands up, the people that are doing drone-based photogrammetry at the moment? Okay, and in agriculture? Oh, come on, Al, you do a bit. Yeah, half put it up. A bit more than that. Okay, so this is just another image. This is just a single image of variability. When we look across a paddock, often you just get up off the ground and you can see that you've got differences occurring across the farm. Right, I'll just jump that one a bit. No, not as easily. So you certainly see some variability, but it's sort of right in your face. Cane, once it's got up to sort of 2 metres or so, you can't see anything anyway. So there's a sort of a lost time. When the farmer's driving around the tractor, they do have some understanding of variability, but spatially they don't. They just sort of know, oh, yeah, there's a bad bit in the block down there, and it's sort of around the middle, whereas the beauty of all of this is it's exact. And they cut the crop, and I can go back in. There's no crop there, I know I'm exactly in that zone. But farmers do have quite an awareness of it. Okay, so here's just some different sensors showing you the same lot of variability displayed in different ways. So the orthomosaic, a plant health filter, which is just an algorithm using the RGB, a digital surface model, and also thermal. So thermal's quite useful. At the moment I've only got a low-res thermal camera, but it's pretty remarkable how easily it picks up that variability with the stressed vegetation being in the white. Okay, so I identify the constraints. Now, constraints could be anything. There's not a single description of what constraints are other than the word saying that it's a constraint. It can do with a whole range of physical things that have occurred. It can do with the seasonal, it can do with diseases, and some of them you'll go one year and it's got this incredible variability, and you go the next year and it's not present. And so and to me this is where the agronomy side of it comes into it, that the map's super important and very powerful, but you need to have the agronomy skills then to be able to sort of go in and say, this is what's going on, or to bring in the ground-based activities that you're going to utilise to determine why that variability is being caused. As you saw in the video, sort of an automatic one that we do is soil coring and soil testing. That's sort of a fairly standard industry one. Not so much the coring. Most people just take 0 to 20 centimetre, sometimes down to 30 centimetre soil samples, so they get some understanding of particularly sometimes the physical and chemical properties of the soil, but it's at low depth. And the other one, because we're in such a very wet region, hydrology plays a very big part of that variability. So you could have the best growing medium, you've done all of your farming activities correctly, and then the block's inundated for 3 or 4 days, and you end up with very poor cane growth, or the roots are down in the saturated zone. So water is a very big consideration, particularly here on these coastal farming systems. Pests, cane grubs, most people would know about cane grubs, but there are a whole range of pests that are around. Cane grubs are one now that we can, to some extent, map out where the cane is being affected by them. So we can sort of start to look at doing a zonal application of the insecticide that affects cane grubs. And weeds. Weeds are a huge thing here in the wet tropics. You get a bit of bare dirt, get a few leaves in your gutter, and suddenly a tree's growing out of it, or the things are growing up over your concrete. Things want to grow here, so weeds are a very big pressure. Okay, so don't quite know why I've got that one in there again. So I'm just going to focus in on one aspect of it briefly, just to drill down a little bit, and I'm going to drill down on the weed mapping and identification part of it. It was a sort of a fairly early thing that I started to do, thinking, well, I can see these weeds, so I can give growers information straight away on being able to target them, not the whole farm, but actually where the weeds are. So there's just an ortho mosaic. You can see the weeds in the imagery, so I just use my eyes. But I can run it through those different outputs that you saw. So here, that's the digital surface model, and in this case these are guinea grass stools that have come up. They come up much faster than the cane. This is ratoon cane, and so they come up very early and make themselves very obvious straight away. This one down the bottom here is just showing the greenness, where they're also they're bigger and they're much greener, so we can find them very easily with the drone mapping. Okay, so what I can do for a grower is we can mark them out. So instead of the grower, in this case, having to go across the whole farm, that's drive up and down the rows trying to find these guinea grass stools, which, by the way, can be hidden with the cane. From a simple mapping exercise, we can actually say to the grower, here's a spatial data set where you can just go down those rows and you'll know where those weeds are and where you've got those sort of pressure zones. Okay, here's an example where I've flown it a couple of weeks later. The grower went in and sprayed. That's the red dot. You can see a sprayed out bit of guinea, and there's a stool that he's missed. So once again, another data set that we can give to the grower to say, okay, you've got a couple of stools left. Growers hate guinea grass, and they'll go to all sorts of extremes to get every stool out of their cane. They obviously compete against sugarcane, and the herbicide that kills sugarcane kills that grass and vice versa. So you can't just go and spray the whole thing or you'll kill your crop at the same time. So it's a really problematic weed. Okay, that's just the red dots now are all the sprayed ones. Yellow ones are the ones that he's missed. Blue ones are new ones that are coming out of a block that's been recently cut. The other way that it works is with what we call out-of-hand cane. So out-of-hand cane is cane that's large enough that you can't get a ground-based machine over. A high-rise, for instance, won't pass over it. And when you reach that stage with a crop, you end up with vines growing on top of the crop, and they squash the crop down, produce seeds, last a very long time. So once again, same mapping exercise. We can actually pinpoint all of the vine patches, and then the grower can make a decision on getting a manned aircraft in or potentially utilise a spray drone technology. That's just showing you the vines on top of the cane where they're in a patch. Here's a couple of weeks later. The bottom one there, you can see the vines have been sprayed out. The one up above it to your right is what the vine looked like beforehand. So we've got that ability to go in, simple flight, and reaffirm or affirm that we've actually got rid of the weed. It's dealt with. Al?
Given that you couldn't get a high rise over that crop because it's out of hand cane, how was that herbicide applied?
So it's applied by a manned aircraft, and there's a couple of things there. They either make a decision to actually spend the money and fly the cane, and that one has a selective herbicide that does kill the vine, doesn't kill the cane, so they can spray the whole block. So they have to make a decision about, look, it's bad enough, I'm going to do something about it this year. And each year is different with the vine. It has really good growing years and poor growing years, so there's those differences. So first off, it's a management decision of, do I do anything? And then if I do I get a plane in, or do I get a contractor to do a spray drone with just the zone, just the patches sprayed out? Okay, spray drones, that's another option that we've got these days. Down the back of the room you'll see the T16. This is an earlier Agris. This is a T16, bigger one that I've got down the back of the room. They're evolving so quickly. It's taken us over a year to get all the licensing through CASA to fly that bigger machine, and there's three new models since I got that one. They're evolving so quickly, still very similar, but they're moving along very fast. So that's the T16 up in the air.
Sorry, Mark, is there a lot of manufacturers of these drone that carry this loads?
Yes, there are a lot of spray drones coming onto the market now, but a lot of them are made in China. China, it's a very big market for drones overall. They make most of the drones, but they also have a big industry around drones spraying crops. We don't do that here in Australia, spatially and a few other reasons. Some of them are not necessarily compliant here in Australia. So I do know of people who just buy them, get them down. They don't match the radio communications licensing requirements here in Australia, as well as other aspects. I've seen it with some of the controllers. It's in Chinese. Yeah, and so there's a few things buyer beware, I would suggest, with drones. A big company like DJI, who I think they've got something like 70 or 75% of the world market for drones, not spray drones, world market. They're a really big player, and yeah, it's really good stuff, very well thought out, and it works. Get out of the box and you're flying around. I'm going to jump that one. Okay, so some of the other things that I'm doing, or you can do with the drones, and how it helps you with spatial information. So here is a centre pivot. It's up on the tablelands, and it's got a centre pivot around the middle. You see the big circular part, and then it's got drip irrigation in these little end bits that you can't get the centre pivot over. But straight away we can see there's a really big range of variability across that, and there's efficiency gains straight away. They're spending a lot of money putting out water on this crop as well as all the other inputs. Okay, what could they start to do with this knowledge to improve either the costs that they're putting in, or to increase the product that they're getting out? I also mentioned that in the video that I'm involved with the EMI, so electromagnetic induction analysis. That's been around for quite a few years. Anyone had experience with EMI mapping of soils? Yeah, Mike? So it's a big thing. It's been around for a very long time and very meaningful. It's really what I've been doing is to see how meaningful it is here in the wet tropics, especially these coastal alluvial systems, how much and how well does it link up to the growth restrictions that we've got on the coast. And I've just been involved. This is the Russell catchment. I think they've driven across about 2,000 hectares with their machine. This is what was the Department of Natural Resources, Mines and Energy. And I flew about 1,000 hectares of it to see how it all matched up. This is some EMI mapping. It looks very similar to the heat mapping from the drone, but it's different depths through the soil profile. As you are all aware, all you GIS people, all of these data layers are just so informative depending on what you're looking for. To end up with a data set that shows you at different levels through the soil profile what's going on is quite an amazing tool. Okay, so precision ag. So we've got precision ag widely across the industry. Tractors are super smart these days. Most growers do A-B lines. Pull up at a paddock, an A-B line, and the tractor drives within a couple of centimetres up and down that row and does whatever the implement's tasked with doing. But there's so much more that smart tractor can do, and particularly around variable rate, where the implement on the back can change the rate of whatever product it's putting out, the activity that it's doing, to match that local environment that it's going through. Okay, I'm just going to run through here, another little bit of a drill down one. This is a yield constraints identification mitigation trial that I've been conducting for a couple of years. So this is one where we've said, okay, all of our technology has shown us all of the spatial variability. Let's go in and really throw a whole lot of resources at what that spatial variability actually is. And remembering that a lot of it is under the ground. So we've got to actually sort of get in there, get the crop off and start digging. In this case here, we've identified some variability across a farm, mapped it out, sort of produced a map showing where it is, and then, now I'm trying to be too tricky here, but it'll come in. This is a very aggressive way of dealing with variation, or variability, but what we wanted to make sure is, let's start from the beginning. We'll go in almost a bit heavy-handed. Let's really dig the place up, understand what's going on, and then we'll taper it down over time and be a bit more precise with what we do. So in this case here, we dug the whole feature out and we wanted to see exactly what was going on. It's a sand feature. It's probably a paleo channel, something like that runs through the farm. And so for a section of it, we moved thousands of cubic metres of soil. We dug it all out, and the piles that you can see beside the feature what we're putting back in again. So we're ameliorating the poor quality sands by putting in mill mud, ash, clay. The grower cleaned all these drains across the property. We put all of that back into that site. So if anything, we've made it probably the most fertile place on the farm. But it was a case of, you've got those restrictions to yield. They've been there forever. Here's a way of being able to understand it and then change those locally growing conditions permanently or relatively permanently. Okay, so this is just the site dug up all around the place. There's the guy clearing the drains to get some silt for us, some finer material to be able to put into the features. And we dug down to the water table, so we were interested to see where does the farm start to interact with the water table, and particularly with these sand features that pass through the property. And it ended up that we hit water at about 3 metres, and it was pure sand, and the further we dug, it just collapsed in, and we thought the excavator was going to fall in the hole eventually, so we had to stop. But it is fascinating to see what's going on in the ground. This is a later one that we've done just recently, where instead of digging out the whole feature, we've just dug out the row. So this farm has controlled traffic. He uses a guidance tractor, and so he's only growing the cane in that zone. So that's the only part of the farm that we need to treat. So we did 17 of these. They're about 10 to 14 metres long, and we moved them all the way across the farm, did all sorts of different amelioration works in those zones to see what we could do for improving it, but also to understand what the features really were under the ground. Okay, here's one where I've done some mapping. This was part of the MIPS, the Major Integrated Project that was run for a few years here, and this is a water treatment off a farm. It's off a banana farm, and to look at the change over time as the native plants that were planted there were able to come in and start to work. This is one where I'm just giving you a bit of a whiz around of all of the uses for the technology. So here is a dam breach. It was a levee that was put in to hold back water and to treat that water with biofilms and grasses and things in that zone. And the people who were in New South Wales wanted to know the extent of the breach and then to be able to work out the earthworks that they had to commission up here. So I flew it in a high resolution 3D with a gridded flight, and just here produced a detailed map of the breach, and they were able to do their analysis sort of on the desk back in New South Wales for the earth contractor up here, the earthworks contractor, to sort it out. Is it a who? Yeah, it is on the other side there. Yeah, spectacular. I think what actually happened is that the wall sank down over the first period, and then that. Yeah. Okay, here's a revegetation site on the Mulgrave River. Can fly over it and then make all sorts of assessments. These assessments are in combination with ground-based activities. Hydrology that we mentioned there before, so we can do the surface mapping to work out what we're going to do with moving water across the landscape, particularly when we're looking at farms that are changing from perhaps cane to bananas or doing some other large land use change. Here's one where we're looking at I'm looking at a pineapple farm. And pineapple farms are sort of scorched earth, lots of sediment leaves them, so it has sediment traps built into it. Here we're looking at the sediment trap being assessed full, and what I could do is assess it full. They dug it out, and I could tell them how much, because I flew it once it was empty. We could do a combination of the two and say you had removed X amount of material from the sediment trap, so that means the sediment trap had captured a certain amount of sediment. Here it is made up into catchments. We've got zones where we can work out what sediment trap is interacting with what part of the farm. We also now do all of our DAF trials are all mapped in advance to understand the variability before we even put a trial out. And then when we've got the trial in, we can now do drone-based assessment. The top right-hand, top left-hand for you guys, one is the multispectral imagery of the zone. Here's just another trial in multispectral. I do multispectral as well as the RGB and the other outputs. Multispectral has got a little bit better, cameras have got a bit better. and I'll just touch on towards the end here very quickly before the mask comes out for the final time, is the 3D mapping. So I'm doing volume assessments at the moment for tree crops, and it's a fantastic tool to be able to get a really high resolution 3D image of the crop, in this case trees, and then to be able to do a volume assessment with height, all the other parameters captured, which would otherwise be done on the ground. Someone on the ground would have got there with sticks and measurement tapes and made all sorts of judgment calls, but we can now use it. There it is, what I end up with at the last stage. And this is just a correlation between the hand-based or the on-ground measurements and the drone mapping. They were very accurate. And here's just a recent trial that I'm doing on grass, just to show the way we can sort of zone it down to very small areas to work out what's going on. Once again, multispectral, just with one treatment. These are lots of treatments across a grass trial, and here I am being able to pull out each individual treatment and then assess. Here I can assess what impact it's had. AI, heaps of stuff going on with AI at the moment, really interesting part of it. Lots of software people are trying to develop the suitable AI products. Automatic recognition of things, these are pineapples, little training area there, and it goes in and finds everyone in the whole paddock. Disease, it's pretty close to it. Didn't see that mask come up here.